Okay, this is my Project 1 code for the cantilever beam optimization. So in here I have my given data, my length, my load, my yield strength, my Young's modulus, my maximum allowed deflection, density of the material, and acceleration due to gravity. Here I initialize variables or numbers for B and H to use later. Here I initialize the matrix C at 0 for weights to be stored and feasibility, which I use to calculate my constraints in a later loop. Here, initialized best weight as infinity, and then best width and height as 0. And then here for my initial loop, I use my length of B values. Second one uses the H values. This here is for rewriting the B and B values to help show the best of each one. I then put these into these equations here to calculate sigma max and sigma buckling. I used this formula here to calculate the deflection. And then here I used these calculated values up here to get my constraints. And then in this if statement, if those two things were true, I went through these calculations, and then my feasibility here, which is I use later on during my plot to show where the constraint is. And then if those are true, then you move on to this one where it replaces the best values with the calculated one to show your best H value, B value, and weight in here. And then if those are not true, then it calculates the feasibility to -1 to show that on the plot. And then here I used a contour F to show you like a colored in version of the plot with my B values, H values, and weight at a level 20. Labeled the X with my width, labeled the Y as height, title it, and then set this stuff up here to make the Y-axis point up. And then I also added in this contour plot to show my feasibility, so it shows the constraints. So if you run that code, you get this plot here. So as you go up into these levels, it is your weight going up. So obviously the further down in the color gradient you are, the better. So your levels here are 5,000, 3,000, and the closer we get to this bottom left corner is the lowest the weight can be without failing, until you get to this black solid line, which is where the infeasibility is -1. Which is where your constraints fail and you are either above your buckling, or you're above sigma max, or your deflection is too great. So obviously you would want to be in here, and then in here your best weight option would be at 229.5 kilograms, and then 0.15 meters for your height and 0.01 meters for your width. And that is my Project 1.